Okay, so in this video, I'm kind of been thinking about, um, I kind of been thinking about summations, and I've been thinking about a lot about limits in mathematics, and also summations of geometric series, or specifically about infinite geometric series. And if I can zoom in on this part, what we have here is this is the formula if you want to calculate the sum of a finite geometric series. I've been using I've been watching a lot of videos on Khan Academy, which is kind of what I've been using to, along with a couple of different books, to learn this stuff, because I didn't learn this stuff when I was in school. So I'm trying to learn this, and pretty soon we'll be trying to learn differentiation calculus at some point. But what we have here is, this is the summation, which is the sigma notation. This is pretty much what we have here. We have the formula of how you would calculate the sum of a finite geometric series. And a sequence is if we had these numbers here, but one after the other, not without the plus sign. A series is when we add all those things together. And sorry about that. Sorry about the wobbliness too. That is the formula. And when we have this sigma notation, what's going on here is the k is what we are starting with, and that's it's what we're starting with, but also kind of what we're sometimes it's what we're the n is what we're kind of is our, I think it's what's called the index as to how we are going from one part of the series to another. And this is the formula. And a limit pretty much is calculating the number of when we're approaching something. And this is the case of when we're approaching a certain sum of an infinite geometric series. That's the sum of, as we're approaching it, and that's the sum of that's the limit of that, and this is what we're going to use to calculate a certain geometric series. So as I zoom out, sorry about the washer also. The whole thing here is, the reason I'm making this video is because of how, given certain circumstances, we can calculate the sum of an infinite geometric series. Even though it is infinite, we can still sometimes calculate the sum of it. So this here is a geometric series where we start out with 2, and we go further with 2/3, and we kind of go further as we square it and cube it and continue further. And assuming that we only had, you know, a few installations of this, minus this part, we could basically use this part here to calculate, like we did here, which is a over 1 minus r, which is the way that we would calculate this. And a over 1 minus r is pretty much a kind of a broken down version of a minus a times r to the n plus 1 over 1 minus r. So a being 2, and r being our, I forget the terms of this because I'm still learning this, so give me some slack, but I'm trying to sort of present this to point out how we can find the sum of an infinite geometric series. The only way that we can do that is if r, and r is 2/3, in each case it's 2/3, if r is greater than 0 or less than 1. That's the only way that we can really calculate the sum of an infinite geometric series. Why are you laughing? Oh, sorry. My fiance's right here, and she was laughing at me. So, given this series, we found that if we wanted to calculate the sum would be 2 over 2 minus 2/3, and I could simplify that into another term, and that would be our sum of this particular geometric series. So I kind of wanted to point that out, and I kind of wanted to think about the actual concept of infinity, given that in this case we can calculate the sum of a infinite geometric series. And I don't know, I find that kind of weird to think about. But I don't know, if you have any tips on helping me learn this kind of stuff, or if you think I messed something up or whatever, I definitely do. I need a lot of I have a lot of work left to do, or a lot of things left to learn about this kind of thing. So comment whatever you'd like down below. Thank you.